Okay, welcome, Math 1, to your last lesson of this school year. You are done after this one. It's a very short one, quick, easy. You should know a lot of this already, or, the elements of this. This should be pretty quick and easy for you. It is one sheet of paper. It is not long and hard. Delta Math assignment, Delta Math homework check for this. It should be much shorter than 2 hours total. So we're going to get right into it. But welcome to the end of the school year. You're done with remote learning after today. Whoop, whoop. Excited, aren't you? All right. Make sure you have a great summer, by the way. Hopefully, we're going to be free and have a good summer, right? Because all of us are not enjoying this stay at home kind of thing. As I'm filming this, we're still at stay at home. So here we go. All right. First one, you know how to multiply a binomial times a binomial. I FOIL it, right? I FOIL it. So when I do this, I get first, outside, inside, and last. I get x squared minus 6x plus 6x minus 36. And when I combine like terms and simplify, I get x squared minus 36. And I alluded to this problem or this type of thing when we are learning how to FOIL before, right? And so this has a special name. When I have an x squared minus, and then a number at the end, this has a special name, especially when that number at the end is a perfect square. And the name for this is a difference of squares. A difference of squares. That is its name, okay? And the reason why is that you should know that the pattern you're going to notice is a subtraction between two terms. And those two terms have to be this. They have to be this. An x squared term, meaning a perfect square, and a perfect square constant. Now, just so you know, it doesn't have to always just be x squared. And I'm going to write here at the top, 4x squared is a perfect square. Why? Because if I take the square root of 4, it is 2. So I know that this is 2x, right? So the idea of x squared being a perfect square, it also works with a 4x squared or 9x squared or 25x squared, 36x squared, 49x squared. As long as the coefficient in front of that x squared is a perfect square, then it fits into this difference of squares. And then the constant has to be a perfect square. It has to be a 1, a 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225 to get us all the way up to 15 of them, right? So this is what that pattern is looking for. A perfect square with a variable and a perfect square constant separated by its subtraction sign. Okay, and with this pattern, we will always have one of each sign when I factor. One of each sign when I factor. And what I mean by that is this, that when I go to factor it, just like we had up here, and I'm circling it right now and I'll highlight it so you can see, one of the binomials is going to be positive and one of the binomials is going to be a negative inside the sign when I factor them, when I go in reverse. Okay? And what that is it really means that I'm going to have an x plus and an x minus, whatever the square root of my constant is. Okay? So if I took a square root of, let's say 30, let's do a different number. If I took the square root of a 25 and I get 5, well, I know that that's the number that's going in here and in here, okay? All right, so that is your difference of squares. And here's the thing about difference of squares and what we're doing here. Difference of squares is something you just have to memorize. You have to notice. You have to be able to just look at it and know how to factor them, because there is no clear-cut way to factor these, okay? This isn't like an a equals 1 or an a greater than 1, which you've just done, right? That's not these. This is by sight and by memory only, okay? Let me erase some of this so I can do the next one. Okay. All right. Now there's another pattern also. Okay. And when I have x minus 4 squared, really what this is saying is x minus 4 times x minus 4, right? The same thing times the same thing. Anything squared, I take it and I multiply it by itself. When I FOIL this, I get x squared minus 4x plus 16. You already know how to do that, so I'm not really slowing down to do that. And then when I combine like terms, I get x squared minus 8x plus 16. This one right here, this trinomial, this quadratic trinomial, right, written in standard form, has a special name. And that special name is a perfect square trinomial. And you're going to ask, well, why does it have a special name? Well, here's why. The C term equals a perfect square, right? The C term is a perfect square. In this case, the 16, the constant, is a perfect square, right? The B value, my B value, in this case, the 8, right? My B value, the 8. Well, that B value is equal to the square root of C plus the square root of C, right? Now, the sign doesn't really matter here, okay? Plus or minus does not matter, okay? The bottom line is this, is that if I take the square root of the C term and I add those two numbers together, like square root of 16 is 4, and I add it to the square root of 4, or the square root of 16, which is 4, if I add the 4 and the 4 together, that comes up with 8, okay? This is why it's a perfect square trinomial, okay? With this pattern, we will always have the same sign when factoring, meaning that I'm always going to have an x plus times an x plus, or I'm going to have an x minus times an x minus. And the reason why is it's always going to be the same, right? The middle term dictates whether or not it's going to be positive or negative, okay? The middle term. If it's a minus middle term, then they're both going to be minuses in there, right? If the middle term is positive, then they're both going to be plus signs in the middle, okay? That is a perfect square trinomial in a nutshell. Now, the thing about perfect square trinomials is you don't have to memorize these. Now, it's really nice if you do, but you can factor this via the AC method anyway and get there, okay? So the only thing knowing perfect square trinomials does for you is the fact that you can look at it and know what it is by memorizing it, right? Otherwise, you can solve these by factoring with the AC method, okay? Knowing this is just about speed, all right? So let's do a few, okay? X squared minus 36. Well, you've already seen that. This factors out to x minus 6 times x plus 6. And I know that it's 1 and the other. 1, I've got it memorized. But 2, in order to get a negative 36, the signs for the last, right, have to be a negative and a positive. Think about FOIL going in reverse. X squared minus 36. Well, what gives me a negative term? Well, the only thing that can give me a negative term is a negative times a positive, okay? X squared minus 81. 81 is a perfect square, right? Square root of 81 is 9. So I know that this is a difference of squares, So x minus 9 times x plus 9, right? And I can write it as x plus 9 and x minus 9. It doesn't matter the order, right? It doesn't matter which binomial comes first. Now, x squared plus 12x plus 36. Remember, I can use a equals 1 to solve this, and that is the AC method, right? I can take the a times the c, find the factors of that add up to the b term and do all that. But I know that that 36 is the square root of 36 is 6, right? I know that 36 is a perfect square of 6, right? And so if I do that, 6 plus 6 is 12. So I know this is a perfect square trinomial because the square root of 36 is 6. I add 6 plus 6 is 12. So I know that this is going to be x and 6 and x and 6. Now I'm going to look at my b term here. Is it positive or negative? Since it's positive, I am positive. So I am x plus 6 squared. All right, the next one, x squared plus 8x plus 16. 16 is a perfect square of 4. 4 plus 4 is 8. So I know that this is x plus 4 times x plus 4, or x plus 4 squared. And then your last two problems of the school year in notes. Now, this one's a little bit more difficult because the first thing you look at is you can't see any perfect squares here. And you're like, oh my God, this isn't factorable. Well, remember, I always got to look at GCF first, right? If I can factor out a greatest common factor first, then I know it might end up being what I want it to be. And in this case, if I factor out a 2, I get x squared minus 16. Now, is 16 a perfect square? Yes. Is x squared a perfect square? Yes. So therefore, this is 2 times x minus 4 times x plus 4. Last but not least, x squared minus 18x plus 81. 81 is a perfect square, right? We know that already. Of 9. 9 plus 9 is 18. So I know that this is x, and this is x. This is a 9 and 9. I'm looking at my b term, and that is a negative, so minus 9 minus 9. So this is x minus 9 squared. Well, congratulations, you have finished your year. Make sure you complete the Delta Math assignment and the homework check, and you're all done for the year. Have a great summer. We'll see you next year. Take care.